Welcome to Suchitra's statistics classes. Today we are going to discuss a problem from Bernoulli distribution. The problem is like this. Show that sum of independent Bernoulli random variables follows binomial distribution. Let x be a Bernoulli random variable with a probability of success p and that of failure q equal to 1 minus p. Therefore, probability density function or probability mass function of x is f of x is equal to p raised to x q raised to 1 minus x, where x takes the value 0 and 1 equal to 0 elsewhere, and p plus q equal to 1. Now let us think about the moment generating function of random variable x. mxt, that is moment generating function, is equal to expectation of e raised to tx, which is equal to summation 0 to 1 e raised to tx p raised to x q raised to 1 minus x. Since the random variable is discrete, so we have summation and f of x of the random variable is p raised to x q raised to 1 minus x. Then combine e raised to tx and p raised to x together, we will get p e raised to t all raised to x. So we can write this as summation 0 to 1 p e raised to t all raised to x q raised to 1 minus x, which is equal to q plus p e raised to t. And we can see that this is independent of the value of x. Let x1, x2, etc. xn be n independent Bernoulli random variables with same probability of success p. Let y be the sum of random variables. Then y equal to x1 plus x2 plus etc. plus xn, that is summation from 1 to n xi. Now let us think about the moment generating function of y. Moment generating function of y, that is myt, is m of summation 1 to n xi t, which is equal to pi I varies from 1 to n mxi t. Pi stands for product. Why we are writing this one? The moment generating function of sum of independent random variables is equal to the product of moment generating function. It's a very famous property of moment generating function. Using this property, we can write pi I varies from 1 to n mxi t, that is pi I varies from 1 to n q plus p e raised to t. Since q plus p e raised to t is the moment generating function of the random variable xi, which follows a Bernoulli distribution. And we know that this expression is independent of x. So this is q plus p e raised to t all raised to n. We know that q plus p e raised to t all raised to n is the moment generating function of a binomial random variable with the parameter n and p. Therefore, we can write y follows b n p. Y is nothing but sum of n independent Bernoulli random variable. We are using the uniqueness property of moment generating function for saying the final result. What is that uniqueness property of moment generating function? Moment generating function uniquely determines the distribution. Or more clearly, if random variables have the same moment generating function, then they must have the same distribution. Therefore, we can say that sum of independent Bernoulli random variables follows a binomial distribution. Thank you for the patient listening. If you can follow this class, like and subscribe Suchitra's statistics classes. Thank you once again.